Hi guys, welcome back to Nerd Talk. I am really excited to have you here, so sit back, relax, and get ready for our 6th journey together. This is part 6 of our journey through the formation of the universe and the solar system. In this episode, we will dive into Uranus, which was discovered by telescope. Let's recap. In the previous video, we saw about Saturn, which is a massive gas giant made mostly of hydrogen and helium, famous for its beautiful rings and many moons. It has no solid surface, experiences extreme conditions, and hosts fascinating worlds like Titan and Enceladus, making it one of the most intriguing planets in the solar system. Now let's study about Uranus, which is a sideways ice giant. Uranus is the 7th planet from the Sun and one of the most unusual worlds in our solar system. It is an ice giant, known for its pale blue-green color, which comes from methane gas in its atmosphere. With the 3rd largest diameter among all planets, Uranus is much bigger than Earth, but still less massive than giants like Jupiter and Saturn. What truly sets Uranus apart is its extreme tilt. Unlike other planets that spin upright, Uranus rotates at about a 90-degree angle, making it appear to spin on its side as it orbits the Sun. This unique feature gives it some of the most extreme seasons in the solar system. Uranus is also a very cold and windy planet, surrounded by faint rings and dozens of moons. Though it may look calm and simple from a distance, it is a fascinating and mysterious world that continues to intrigue scientists. Discovery of Uranus, a planet found by curiosity. In 1781, a musician turned astronomer named William Herschel pointed his telescope at the sky and noticed something unusual. It was a new planet, the first ever discovered using a telescope. Far beyond the warmth of the sun, past the orbits of giant planets, lies a pale blue world, drifting in silence, Uranus. When Voyager 2 flew past it in 1986, it captured a haunting image, a smooth blue-green sphere floating in darkness. No dramatic storms like Jupiter, no dazzling rings like Saturn, just calm, cold mystery. But don't let that calm fool you. Uranus is one of the strangest planets in the entire solar system. It spins sideways. When William Herschel discovered the new planet in 1781, he wanted to honor his patron, King George III of Britain, so he proposed the name Georgium Sidus, which means George's star. At the time, this made sense politically. Herschel had gained recognition and support from the king, and naming a planet after him was a way of showing gratitude. For a while, this name was even used in Britain, and some astronomers referred to the planet by this royal title. However, outside of Britain, the name didn't sit well with the scientific community. Astronomy had long followed a tradition of naming planets after figures from classical mythology, such as Mars and Saturn. Giving a planet a modern political name broke that pattern and felt out of place to many European astronomers. It also risked making scientific naming influenced by national pride rather than universal agreement, which scientists wanted to avoid. That's when Johann Elert Bode proposed a more fitting alternative. He suggested naming the planet Uranus, after the ancient Greek sky god Uranus. This choice was not random. It followed a meaningful pattern in mythology. Uranus was the father of Saturn, and Saturn was the father of Jupiter. Since the new planet lay beyond Saturn in the solar system, naming it Uranus maintained a symbolic cosmic family tree. Over time, Bode's suggestion gained widespread acceptance across the international scientific community. By the late 18th century, Uranus had replaced Georgium Sidus entirely. The name not only restored the tradition of mythological naming, but also gave the planet a timeless identity, one that connects it to the ancient human fascination with the sky and the universe. Why Uranus was considered heaven. In ancient Greek mythology, Uranus wasn't just a god who lived in heaven, he was the sky itself. The Greeks imagined the universe very differently from how we do today. To them, the Earth was a flat or rounded land, and above it stretched a vishal, dome-like sky. This sky wasn't empty space, it was a divine being. That being was Uranus. He represented the entire heavens, the endless blue expanse that covered the world. Uranus was considered heaven because he was the uppermost, all-encompassing layer of existence, the place where light came from, where celestial bodies moved, and where divine power seemed to originate. Everything above Earth, stars, light, and the vast unknown was associated with him. Slide 14. In mythology, Uranus was also the father of Cronus, Saturn, and the grandfather of Zeus, Jupiter. This created a symbolic hierarchy. Uranus equals the sky, heaven. Cronus equals time and the ruling titan. Zeus equals ruler of gods and the heavens after. So when astronomers named the planet Uranus, they weren't just picking a random mythological name. They were choosing a figure that literally represented the heavens themselves, making it a perfect name for a distant world high above and far beyond Earth. Around 4.5 billion years ago, the solar system was not the calm, organized place we see today. It was a violent, chaotic cloud of gas, dust, and debris called the solar nebula. At the center, gravity pulled most of this material together to form the sun. Around it, the remaining particles began to collide, stick, and grow, slowly building the planets. In the outer regions of this young solar system, where temperatures were extremely low, lighter gases like hydrogen and helium mixed with icy materials such as water, methane, and ammonia. In this freezing zone, Uranus began to take shape. Small, icy, and rocky fragments kept colliding and merging, forming a growing core. As this core became more massive, its gravity pulled in surrounding gas and icy material, eventually forming what we now call an ice giant, similar to its neighbor Neptune. But here's where things get interesting. Scientists believe Uranus did not originally form exactly where it is today. In the early solar system, the giant planets likely migrated due to gravitational interactions with each other and with leftover debris. Uranus may have formed closer to the Sun and then slowly moved outward over time, settling into its current distant orbit nearly 2.9 billion kilometers away. This migration helps explain the current arrangement of the outer planets and is supported by modern planetary formation models. Now comes the most dramatic part of Uranus's story, its bizarre tilt. Unlike every other planet, Uranus is tilted by about 98 degrees, essentially lying on its side. The most widely accepted explanation is a massive collision early in its history. Imagine a young Uranus, still forming, suddenly struck by a huge object, possibly as large as Earth. The impact would have been powerful enough to knock the planet over, permanently changing the direction of its rotation. Some newer theories suggest it might not have been a single impact, but rather multiple smaller collisions that gradually tilted the planet over time. Either way, the result is the same, a planet that spins like a rolling ball instead of a spinning top. This violent past explains a lot about Uranus today, its strange rotation, its extreme seasons, and even aspects of its internal structure. What looks like a calm, quiet blue planet now was once shaped by intense cosmic chaos and collisions. So Uranus isn't just unusual by accident. It's the product of a dramatic and turbulent origin story written in the earliest days of the solar system. Uranus is truly massive, but its size becomes even more impressive when you compare it to Earth. If Earth were shrunk down to the size of a small coin, Uranus would be about as large as a softball. In reality, Uranus has a diameter of about 51,118 kilometers, making it the third largest planet in the solar system. Smaller than Jupiter and Saturn, but still enormous compared to our home planet. Despite its size, Uranus feels distant and almost forgotten because of how far away it is. On average, it orbits the Sun at a distance of about 2.9 billion kilometers, which is roughly 19 astronomical units, AU. 1 AU is the distance between Earth and the Sun. This means Uranus is nearly 19 times farther from the Sun than Earth, placing it deep in the outer solar system alongside Neptune. At such an extreme distance, even light struggles to reach it quickly. Sunlight, which takes only about 8 minutes to reach Earth, needs nearly 2 hours and 40 minutes to travel all the way to Uranus. By the time sunlight arrives, it is much weaker, giving the planet its dim, cold environment. Because of this distance, Uranus receives very little solar energy. This is one of the main reasons why it is one of the coldest planets in the solar system. The sun would appear much smaller and fainter in its sky, more like a bright star than the powerful, blazing disk we see from Earth. So even though Uranus is a giant in size, its vast distance from the sun makes it a quiet, cold, and remote world, far removed from the warmth and brightness of the inner planets. Orbit and rotation, the planet that rolled over. This is where Uranus truly stands out as one of the strangest planets in the solar system. Most planets, including Earth, rotate like upright spinning tops. Their axes are only slightly tilted, which is why we experience relatively normal seasons. But Uranus completely breaks this pattern. It is tilted at an angle of about 97.77 degrees, meaning it is almost lying flat on its side as it orbits the sun. To visualize this, imagine a ball rolling around in a circle instead of spinning upright. That's exactly how Uranus moves through space. Instead of its poles being top and bottom, like Earth's north and south poles, they are positioned more like the front and back of the planet during its orbit. This unusual orientation makes Uranus look like it's rolling along its path around the sun. In terms of time, Uranus rotates quite quickly. One full rotation, one Uranian day, takes about 17 hours, which is shorter than an Earth day. However, its journey around the sun is incredibly long. One Uranian year lasts 84 Earth years, meaning it takes decades for the planet to complete a single orbit. Now, this extreme tilt creates some of the most bizarre seasons in the entire solar system. Because Uranus is essentially on its side, each pole ends up pointing directly at the sun for a long period. This results in one pole experiencing continuous daylight for about 21 Earth years, while the opposite pole is plunged into complete darkness for the same length of time. After half an orbit, the situation reverses. Light becomes darkness, and darkness becomes light. These are not just seasons like summer and winter on Earth. They are prolonged extremes that last for decades. The equatorial regions, meanwhile, experience rapid transitions between light and dark as the planet rotates, adding even more complexity to its climate. Another unusual feature is the direction of its rotation. Uranus rotates retrograde, meaning it spins in the opposite direction compared to most planets. The only other planet that shares this trait is Venus. This backward spin, combined with its sideways tilt, makes Uranus one of the most dynamically unique planets in terms of motion. All of these characteristics, its sideways orientation, long years, extreme seasons, and backward rotation, are likely the result of a violent past, possibly involving massive collisions during its formation. What we see today is a planet that doesn't just orbit the sun. It does so in a way that challenges almost every normal rule of planetary motion. As you approach Uranus, the planet appears calm and beautiful, a smooth, pale blue-green sphere floating silently in space. But as your spacecraft begins to enter its atmosphere, that peaceful appearance quickly fades. You are surrounded by a thick layer of gases, mainly hydrogen and helium, with methane giving the planet its distinctive blue color. The deeper you go, the more intense the environment becomes. Powerful winds, reaching speeds of up to 900 kilometers per hour, rush past the spacecraft, carrying clouds in strange and ever-changing patterns. What looked like a quiet world from afar is actually dynamic and turbulent, with sudden storms forming and disappearing in the icy atmosphere. Continuing your descent, you prepare for a landing, but soon realize there is no surface to land on. Uranus does not have solid ground like Earth. Instead, the atmosphere gradually becomes denser and heavier, turning into layers of thick, fluid-like material. The boundary between gas and liquid disappears, and you simply keep sinking deeper. Pressure increases rapidly, squeezing everything tighter and tighter. The concept of a surface loses all meaning here, as there is no clear point where the atmosphere ends and the planet begins. As you move further inward, the environment transforms into a vast, dense layer composed of water, methane, and ammonia, not in familiar forms, but compressed into a hot, heavy fluid. This is the true nature of an ice giant. Darkness surrounds you, and temperatures begin to rise sharply despite the freezing outer layers. The pressure is immense, far beyond what any spacecraft could withstand, and the materials around you behave in strange, unfamiliar ways under such extreme conditions. At the deepest level lies a small rocky core. Here, temperatures soar to nearly 5,000 degrees Celsius, revealing a surprising truth about Uranus. It may be freezing on the outside, but it hides an intensely hot interior. This journey shows that Uranus is not a calm, simple planet at all, but a complex and extreme world where crushing pressure, violent winds, and hidden heat define its true nature. Unlike the bright, dazzling rings of Saturn, the rings of Uranus are much more subtle, dark, and mysterious. They don't immediately stand out, which is why they remained undiscovered until 1977, when astronomers noticed something unusual: stars briefly dimming as Uranus passed in front of them. This revealed the presence of rings blocking the starlight. Uranus has 13 known rings, arranged in two main groups: inner and outer rings. The inner system consists of narrow, tightly packed rings that are mostly dark gray in color. These rings are made up of relatively large particles, possibly chunks of rock and ice coated with dark material, which is why they reflect very little sunlight and appear faint. Beyond these lie the outer rings, which are more widely spaced and slightly different in appearance. One of them has a reddish tint, similar to dusty rings seen elsewhere in the solar system, while the outermost ring has a bluish color, likely caused by very fine particles scattering light, somewhat like the effect seen in Earth's sky. What makes Uranus's rings especially interesting is how narrow and sharply defined many of them are. Instead of being broad and bright like Saturn's, they look more like thin, delicate rings encircling the planet. Some rings are even surrounded by faint belts of dust, adding to their complex structure. Scientists believe these rings are relatively young, possibly formed from the debris of shattered moons or objects that were torn apart by Uranus's gravity. Over time, collisions and gravitational interactions may have shaped them into the thin, distinct rings we see today. So, while Uranus's rings may not be as visually spectacular as Saturn's, they have their own quiet charm. Dark, delicate, and full of hidden complexity, like a subtle signature around one of the solar system's most unusual planets. Uranus has 28 known moons, and they are unlike the moons of any other planet, not because of how they move, but because of what they're called. While most planets name their moons after figures from Greek or Roman mythology, Uranus breaks tradition completely. Its moons are named after characters from the works of William Shakespeare and Alexander Pope, giving the entire system a distinctly literary and artistic vibe. This means instead of names like Ares or Apollo, you get names like Titania, Oberon, Miranda, and Ariel, characters taken from famous plays and poems. For example, Titania and Oberon are the fairy queen and king from Shakespeare's A Midsummer Night's Dream. It's almost as if Uranus has its own floating theater cast orbiting around it, making it feel more like a world inspired by storytelling than by mythology. In terms of structure, these moons vary quite a bit. The inner moons are generally small and composed of a mixture of water ice and rock. They are irregular in shape and heavily cratered, suggesting they have experienced many impacts over time. Some of them also interact with Uranus's rings, helping to shape and maintain their structure through gravitational effects. The larger moons, like Titania and Oberon, are more spherical and show signs of geological activity in the past, such as cracks and valleys on their surfaces. This suggests that they may have once had internal heat that caused their surfaces to expand and fracture. Further out, the outer moons are more mysterious. Many scientists believe these could be captured objects, possibly asteroids or fragments that were pulled in by Uranus's gravity long ago. Their irregular orbits and unknown compositions support this idea. Overall, Uranus's moons form a unique and fascinating system, scientifically important, but also culturally distinctive. While other planets look to ancient gods for naming inspiration, Uranus stands apart, orbiting the sun with a cast of characters straight out of classic literature. Exploring Uranus is important because it helps scientists understand a type of planet called an ice giant, which is very common in the universe, but still poorly studied. Unlike Jupiter and Saturn, Uranus has a unique structure, extreme tilt, and unusual magnetic field, making it a key to understanding how planets form and evolve. Studying Uranus can also reveal insights about its atmosphere, internal composition, rings, and moons, and help scientists compare it with Neptune. Since we've only had one brief visit from Voyager 2, exploring it further could unlock many unknown secrets about our solar system and even distant planetary systems beyond it. Uranus has a highly unusual and off-balance magnetosphere because its magnetic field is tilted about 60 degrees from its rotation axis and is also shifted away from the planet's center. Unlike Earth's stable field, this creates a distorted and constantly changing magnetic environment. As Uranus rotates on its side, the magnetosphere twists and wobbles, producing irregular auroras and a corkscrew-shaped magnetic tail that stretches millions of kilometers into space. This strange behavior makes Uranus very different from planets like Earth and Jupiter, and it is still not fully understood by scientists. Missions to Uranus, a lonely visit and big future plans. Uranus is one of the most mysterious planets in our solar system, not because we don't care about it, but because we've barely visited it. As of 2026, humanity has only had one close encounter with this distant world, and even that was just a quick flyby. Voyager 2, 1986, the only visitor. The only spacecraft to ever explore Uranus up close is Voyager 2. Launched by NASA on August 20th, 1977, it was part of an ambitious mission to explore the outer planets. After traveling for nearly a decade through deep space, Voyager 2 finally reached Uranus on January 24, 1986. As it flew past the planet at a distance of about 81,500 kilometers from the cloud tops, it gave humanity its first, and so far only, detailed look at this icy giant. During its brief visit, Voyager 2 made several groundbreaking discoveries. It found 10 new moons and 2 additional rings, expanding what we knew about the Uranian system. It also revealed something completely unexpected. Uranus has a highly tilted magnetic field, angled about 60 degrees away from its rotation axis, making it one of the strangest magnetic environments in the solar system. The spacecraft also captured the first close-up images of Uranus and its moons. Interestingly, the planet appeared quite plain compared to other giants, almost featureless, though later observations showed it can be more dynamic than it first seemed. After completing its flyby, Voyager 2 didn't stop. It continued onward to visit Neptune in 1989 and eventually moved beyond the planets altogether. Today, it travels through interstellar space, carrying a golden record as a message from Earth. And that's it. That single flyby remains the only time humanity has ever seen Uranus up close. Future missions: the Uranus Orbiter and Probe. Even though Uranus has been largely ignored compared to planets like Mars or Jupiter, that might finally change. In 2022, a major scientific roadmap called the Planetary Science Decadal Survey identified a mission called the Uranus Orbiter and Probe, UOP, as the top priority flagship mission for the coming decade. The idea is a huge leap forward compared to Voyager 2. Instead of just flying past, this mission would place a spacecraft into orbit around Uranus, send a probe directly into its atmosphere, study the planet's interior, weather, magnetic field, rings, and moons in detail. Scientists are especially excited because Uranus represents a whole class of planets, ice giants, that are common in the universe but poorly understood. The proposed launch window is in the late 2030s, using a gravity assist from Jupiter to gain speed and reduce travel time. However, as of 2026, this mission is still in the planning and concept stage. It has not yet received full approval or funding.
Why so few missions? The biggest challenge is distance. Uranus lies about 2.7 to 2.9 billion kilometers from Earth, making it incredibly hard to reach. Even with advanced spacecraft, a mission can take 10 to 13 years just to arrive. On top of that, missions often rely on gravity assists, using planets like Jupiter to slingshot spacecraft forward. But these opportunities only occur during specific alignments that happen once every few decades. So sending a mission to Uranus isn't just expensive, it's also a matter of perfect timing.
Potential for life? A harsh reality. If you were hoping for alien life here, yeah, not happening. Uranus is brutally cold, with temperatures dropping to around negative 224 degrees Celsius. The atmosphere is thick, toxic, and chaotic. Pressure increases so dramatically that even the toughest spacecraft wouldn't survive. Life as we know it wouldn't stand a chance.
Thanks a lot for watching. If you are liking the videos, please do subscribe, like, and share with your loved ones.